So today's topic, proportional length. If you have these two segments like this, where AL over AB is equal to CM over CD, the length of these segments, guess what? We say these segments are divided proportionally. And why do we need this definition? The next theorem is going to use this definition. Okay? Does this make sense?
You have to write that.
Go ahead, yeah, I'll wait. So write this down. Write down what it means when the segments are divided proportionally. Basically, if the ratio of the segment of these two segments are equal to the ratio of the other two segments, right? You have this proportion. Then that's what we mean. And we're going to need this for our next theorem, okay? So knowing this definition, we could say this. Oh, okay, so this theorem has a name, triangle proportionality theorem. Sorry. Triangle proportionality theorem. And as I mentioned before, it's going to use the definition. It says this: if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. So there is that definition. It divides the sides proportionally. And here's a picture. So if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. Go ahead and write this down, and thankfully it's got a name, and let's think about it as you write this down. Think about what this is saying, okay? Alright, I'll wait. Alright, so take a look at what it says. What do you think? So it says if a line parallel to one side of a triangle. In this picture, which line are they talking about? Three people? How about Jonathan? PQ is correct. You see? PQ, it says right here. PQ, the line PQ is parallel to RS. If that happens, okay, what are they saying? What's the end result? Yeah, Chan?
The sides are divided proportionally.
The sides are divided proportionally. Which sides?
The TR and
Yes,
TS.
TR and TS. So PR over PT is equal to what?
TQ.
No. If I say PR first, PR over PT is equal to QS over
QT.
TQ or QT. Does that make sense? Right? Isn't this the second part of the definition of similar triangles? Corresponding sides of similar triangles are in proportion. Isn't it that?
Yeah.
I'm gonna say yeah, it's the same thing. I'm gonna say no, it's not. Yeah, it is not. It's not saying the same thing. Why not, Nicholas? Because it looks similar. I don't know.
It's saying that the sides of two congruent triangles are in proportion.
You mean two similar triangles?
Two similar
Uh-huh.
triangles are in proportion.
Hmm?
Where this one is just the one triangle and its sides.
Exactly. So, is PR a corresponding side of a triangle? Is this a side of a triangle? No, it's part of it. It's not the whole side, is it? So, what would the definition of similar triangle say? Not this, but it would say what? TP over TR is equal to what? TQ over TS if the two triangles are similar. You see what I mean? This is not what that's saying, right? It's not saying that, is it? Do you see the difference? This is only saying this part of this triangle, RP over PT is equal to QS over TQ. Does that make sense? Yes? Okay, so how do we get, so of course, interesting part is then solving this. How are we going to say it? Or what are we going to say first? Let me give you a given first here. First one I'll give you. See you? Given. I'm sorry. Here, given. Then what should we say next? If PQ is parallel to RS, something should be sort of, something should naturally come. Three people? Come on. If PQ is parallel to RS, what can you say here? Nicole? Sure, angle 1 is congruent to angle 2, isn't it? Right? Why, Nicole? Good. If two parallel lines are cut by a transversal, aren't these corresponding angles? Can I just write corresponding angles are congruent? Like you did on your test? No, you can't do that. You have to. That's only true if two lines are parallel and cut by a transversal. Okay. Well, with the same reason, what about angle 3 and 4, class? They're also congruent, aren't they? Because aren't these corresponding angles of this transversal, TS, right?
Yeah.
Here are the two parallel lines. Is that okay? So I'm going to say that next. Okay, great. Then, what should we say next here? Should be pretty obvious. After this, okay, go ahead. Discuss with your group. What are you going to say next? What are you going to say? All right, Iveta, what do you think? So what? If angle 1 is congruent to angle 2, angle 3 is congruent to 4, what can we say next? Yeah, by angle postulate, what's the result? Correct. These two triangles are similar. Isn't that right? Okay, that's good. I'm sorry. Here you go. Okay, so we got the two triangles similar by AA. That's easy. Do we need to mention that they're sharing angle T?
No.
You don't have to because we already have two, right? Angles of one triangle congruent to two angles of the other. Then what? So what? What are we gonna do? Well, what do you? So we want to get to something about RP and PT and SQ and QT. We can't say that yet, but we could say something about PT and QT, can we not? What do you know about PT and QT and so forth? Young?
PT over QT equals RP over SQ.
Yeah, the corresponding sides of similar triangles are in proportion. So we want PT on the bottom, don't we? So what should we say? How about we start with RT over what? PT over what? ST over QT. Could we say that? Do you see why I did that? Because don't I want PT on the denominator and QT on the denominator? Right? You see what I mean?
Yeah.
Okay, but that's not what we wanted to say, right? The numerator is different. We don't want RT. We don't want this whole thing. We want right here. We want PR and then QS. Right? What are we gonna do next? So don't we have to mention something about RP and SQ? What do you guys know about RP and SQ? What can we say about RP and SQ? Something sort of. We have to mention these segments somehow. Grace? Yeah, let's just write that down by what is that? What is the reason? Segment. Yeah, segment addition postulate. Could we say this? It's kind of tough, right? By doing it, separating this way, right? We could kind of talk about parts of these sides. Isn't that right? And of course, in place of RT, what are we going to write down? We're going to substitute RPO plus PT. In place of ST, what are you going to write? SQ plus QT. Okay, that's nice. By substitution. Okay. But we still don't have what we wanted to say. But I claim to you, we just need one more step, and we could get to the statement that we want to get to. Some people see it. Go ahead, discuss with your group. How would you do this? Go ahead. What do you guys think? If you know it, see if they agree with you. Go ahead, everybody. Okay, many of you got the right answer, but yeah. Take a look at the property of proportion. Which part am I interested in? D. Look at D. What do you know about A plus B over B equals to C plus D over D?
It's congruent.
It's equivalent to AB equal to C over D. You guys remember this?
Yeah.
Right, it's kind of going backward, isn't it? Basically, remember how we added both sides by 1 and made it B over B. On the right side, we made it D over D. You guys remember that?
Yeah.
So let's go back to where we were. If I can find it. Try close. Give me a sec. Here we go. So from here, what can we say here next? Using that property of proportion, that part D, what can we say here? Jet, what are we going to say?
For D, like.
So from this step, what are we going to say next? We're going to say we got PT plus RP plus PT over PT. Can't you separate this into two fractions? Isn't the same?
RP over PT plus PT
Equals to SQ.
SQ over QT plus QT over QT.
Yeah, and you could separate it that way using substitution, but you could just do this whole thing in one step, which is equals.
SQ over QT.
Yeah, exactly. We could actually go from here. What's the reason?
Property of
Yeah, property of proportion, right? Does that make sense? And look, they're so nice. They even right, gave you what page this is in and which part of property of proportion. Isn't that nice? Yeah, Amy?
Wait, for the reasoning, can you just put like subtraction property of equality?
Oh, if you're gonna write down subtraction property of equality because you subtracted 1 from both sides, then you would have to rewrite 6 as, just like how Jet was doing, RP over PT plus PT over PT equals SQ over QT plus QT over QT, which is by substitution. Then you're gonna say, oh, RP over PT plus 1 equals to SQ over QT plus 1, which is by substitution. And then you're gonna subtract both sides by 1 by subtraction property of equality. So yeah, you could do that, but you would need a couple more steps. But isn't this nice? You could just go from 6 to 7 step by using the property of proportion, right? But you could do it that way. Any question? Does this make sense? You guys got that? Okay, so knowing this, and all the other ones that we learned so far about these, first of all, property of proportion and the definition of similar triangles, the second part, the corresponding size of similar triangles are in proportion. I claim to you that you could fill out these things. Okay, whoops. Fill this out. So we know that, where did I get this from? A over B equals to C over D. Where did I get that from? Yeah. Did I get that from property of proportion? That's the theorem we just proved, which is called the what? Triangle proportionality theorem. So I got that, okay? So knowing this, can you fill out the rest of these? Go ahead. Notice, look at, for AC, I could actually represent AC in 2 different ways. Go ahead, everybody try and see if you can fill out the blanks. Okay, go ahead. So knowing this theorem and using the property of proportion and the second part of the definition of similar triangle, corresponding size of similar triangles are in proportion, you could fill out the rest of these. Go ahead. This is going to be, I want you to do this yourself now. Help each other out. Go ahead, everybody try. Alright, so let's do AC first. Okay. By the way, like I said, guys, you're gonna need to know these. You could have other ones, but I'm going to show you the 6 of them. You're gonna need to know these proportions for your homework tonight. Okay. So A to C as to what can you say? B to. Okay. What else could you say? A to. Well, let's come back to that a little later. Let's look at A to J. What can you tell me about A to J as to what? C to K. Would you not agree? So knowing all the property of proportion and definition of similar triangles and so forth, we could fill this out. What about B to J? Where is it? B to J as to D over K. What about B to D? B to D as to what? B to D as to A to C. Okay. All right. Alright. Actually, B to D. That's kind of like. Okay. What about B to D as to? Okay, we could do B to D. Another one. B to D as to J over. Is it K over J or J over K? J over K, isn't it? Okay, so B to D you could do. You could represent 2 ways. Oh, A to C you could also do it. See, J over A to C as to J over K also. So look, A to C as to A to C as to J to K. They all work out. So you should know these properties, okay? I mean, not properties. You should need these proportions, okay? When you do your homework tonight. Is that okay? Any question as to why they work? Okay, these are a combination of definition of similar triangles, property of proportion, and triangle proportionality theorem. You could always do this, right? You could show this algebraically also if you like. But you guys get the idea? Okay. Any question? All right, let's do some examples. And knowing this, okay, let's do. Okay, I'll wait. Knowing this, we could do some examples here. Wait a minute. B to D. Didn't we do this? Isn't this right here? This and this. Aren't they the same thing? Well, you wrote. Yeah. What property is this? Yeah. So you don't need to write this again. So. Alright. So I don't need that. I'm gonna erase this one. Okay. So there. You need these 6 of these. Okay. All right. Of course, you could like flip all of these, right, and get twice as many, right? but it's the same thing. All right. Right, guys, listen. Could I write, instead of this, could I write B over A is equal to D over C and so forth? Write all of its reciprocals, right? Yeah, but I don't need to do that, okay? So just know these 6. They're all, you're going to need to know these proportions. Okay? Here we go. Try example 1. If I have the triangle like this and MN is parallel to ST, because of triangle proportionality theorem, I claim to you that we could figure out the ratio of Tn to Nr, Tr to Nr, and Rn to Rt. Okay, go ahead. Everybody try this. You could help each other out too. Go ahead. Everybody try.
No one does it.
So, Kristen, how would you do Tn over Nr? Oh, okay. Let me help you. Remember the previous theorem? Look at Tn right here. Tn over Nr. You see how we have a triangle, right? And this Mn is parallel to St. What do you know about these two sides? They are divided proportionally, right? So Nt over Nr is the same as what? Yeah, because it's Sm over Mr, right? So you're right, it's half. Does that make sense? You guys get the idea? Does this mean that Rn, the length of Rn is 2 and length of Tn is 1? No, it doesn't mean that their length are these, but what? When you write their ratio, it'll be half. Does that make sense? That's important to understand, guys. We're now actually saying the length of Rn and Nt are like 2, 1. Hello? Does that make sense?
Yes.
Alright, what about then Tr to Nr? Esther, what would you say? Tr to Nr would have the same ratio of what? 3 to 2, why? So if you're gonna compare, just tell me which length we need. If I'm comparing Tr to Nr, what do we need from the other side? Sr to which what? Yeah, which is what's Sr? 9. What's Mr? 6. How many people got 3 over 2 for the second one? Okay, good. What about the last? Rn over Rt. Who have an Pomon? What do you think? How many people agree with Pomon? It is correct. It is 2/3 because if I'm comparing Rn to Rt, what do we need? Rm to Rm to what? Rs. So therefore you get 2/3. Correct? Any question? Okay. May I go to the next one here? Here we go. Let's look at our corollary. If two parallel lines, so it comes from the previous theorem. If three. If 3 parallel lines intersect 2 transversals, then they divide transversal proportionally. And here's the picture. And of course, fun part is to figure out why this is true. Right? Prove this. So if you got 3 parallel lines, Rx, Sy, Tz, and it's cut by 2 transversal, Rt and Xz, look at what happens. If this is true, you get Rs over St equals to Xy over Yz. Hey, isn't this same as that theorem before? No, the theorem has what? You have to have a triangle. Do I have a triangle right now? No. Guess what? That red dotted line is going to help you though. Yeah, you're gonna have, how many triangles are you gonna have? 2 of these. Does that make sense? So write this down and let's figure out why this is true. So I'll wait. Go ahead and write it down. Anybody see how we could prove this? Corollary: if 3 parallel lines intersect 2 transversals, then they divide the transversal so proportionally. How many triangles do you see here?
4. 3.
Yeah, there are a whole bunch of them, but with this, actually,
5.
right. Okay, but what I meant to say, sorry, is how many triangles do you need with that XT as the auxiliary line. 2. Which two triangles are we interested in? XTZ and XTR. One on the left right here. Okay. And the one on the right here. Because, what can you tell me about these two triangles? Their size will be divided proportionally because of the previous theorem, right? So let's call this one here A, B, and then C, D. And I'm going to call these E, F. These segments. Is that okay? So, well, I could rewrite this as, instead of RS, what can I say? A over, instead of ST, what can I write? B equals to, instead of XY, what can I say? C over D. Okay, let's look at the blue triangle. Is that okay? When you look at the blue triangle using triangle proportionality theorem, right? Because you know that SY is parallel to RX, correct? You have 3 parallel lines. What can you tell me about A over B equals to? E over F. Let's look at the red triangle. You know that this NY or SY is parallel to TZ, isn't that right? So what can you tell me about E over F? Using the triangle proportionality theorem, you could say it equals to C over D. And look, can we use transitive? So what's the end result? Oops, A over B. Oh, doesn't erase. A over B is equal to C over D. And isn't that what we wanted to prove at the end? Oh, I mean C over D. Isn't that right? Does that make sense? Do you see how we're using transitive and using the theorem twice? Any question? Okay. All right. We'll finish the rest of them tomorrow. Is that okay? All right. Good.